Imagine trying to list all possible bitwise OR results from every subarray in an array. Sounds like a brute force nightmare, right? But what if I told you there's a clean, elegant way to solve this in near linear time, without generating a single subarray? Hey everyone, welcome back to BugNoJutsu, the dojo where we master the grind, decode patterns, and conquer LeetCode one technique at a time. Today, we're taking on an underrated bitwise gem, LeetCode 898, Bitwise ORs of Subarrays. Let's break it down. You're given an array of integers, and your task is to find out how many unique results you can get by performing a bitwise OR on every possible non-empty subarray. A subarray here means any continuous segment of the array, you can't skip elements. Each subarray must have at least one element. For each of these subarrays, you calculate the bitwise OR of all its elements. This operation compares the binary representations of numbers and sets each bit to 1 if it's 1 in any of the numbers involved. Once you've done that for every subarray, you collect all the different OR results you got, remove duplicates, and return the total number of distinct values. In short, the challenge is to efficiently explore all possible subarrays, apply bitwise OR, and count how many unique values you can obtain. Let's take the array 1, 1, 2 to see how this works. First, look at all possible subarrays 1, 1, 2, 1, 1, 1, 2, and 1, 1, 2. Yes, 1 appears more than once, but remember, we're only counting distinct OR results. Now, calculate the bitwise OR for each subarray. The single-element subarrays 1, 1, and 2 give us OR values 1, 1, and 2. The subarray 1, 1 gives 1 or 1 is equal to 1. 1, 2 gives 1 or 2 is equal to 3. Finally, 1, 1, 2 also gives 3. So what are our distinct OR results? We get 1, 2, and 3. That's a total of 3 unique values. Hence, the output is 3. Now, let's break down how to solve this efficiently. A naive approach would be to generate all subarrays, compute their ORs, and track the results. But that's inefficient, it could take quadratic time. Instead, we use a dynamic approach that builds on the idea of propagating OR values. For every number in the array, we look at the OR values of all subarrays that ended at the previous element. Then, for the current number, we compute the OR between it and each of those previous results. This way, we extend all the previous subarrays by one element. We also include the number itself, since it forms a one-element subarray. At each step, we gather these new results into a set and merge them into a global set that holds all distinct OR results we've seen so far. This technique drastically reduces redundant computations, and leverages the fact that bitwise OR is monotonic, meaning once a bit is set, it can't be unset in future ORs. Let's talk about complexity. The time complexity is O, n times log m, where n is the length of the array, and m is the maximum number in the array. In practice, this is very efficient because bitwise OR operations are bounded, most numbers have at most 30 to 32 significant bits. The space complexity is also O, n times log m, in the worst case, due to the storage of intermediate OR results in sets. But again, the number of unique OR values is typically small, especially for small or repetitive arrays. Here's where it gets interesting. This problem is a great example of where brute force fails and understanding bitwise behavior shines. The key insight is realizing that OR values form a limited and non-reducing set, they only grow or stay the same. Also, this solution generalizes well. The same technique can be extended to similar problems that involve combining subarrays using other monotonic operations like bitwise and/or XOR, though with some tweaks. Finally, it's a great LeetCode medium that teaches you how to balance correctness with efficiency, something every real-world coder needs. And that's how you outsmart brute force with bitwise brilliance. If you found this video helpful, don't forget to like, share, and subscribe to BugNoJutsu, where we don't just solve problems, we grind smarter. Drop your doubts or variations of this problem in the comments, and let me know if you'd like to see this logic extended to ANDs or XORs in subarrays. Until next time, keep learning, keep grinding, and remember, the bug is nothing when you know the jutsu.